Okay, class, I wanted to take another chance here to show you about calculating your ice weight. Now, we've already calculated machine friction, and we've learned how to calculate our desired dough temperature. And we've already looked at those two equations, and now we've also determined what our desired water temperature should be in order to get to our desired dough temperature. And sometimes, in the case of our first bread, we ended up having to warm up our water. We needed 103, remember, when we did our calculations for our French bread. Now, that was based on my environment in the area that I was in, based on our room temperature, water temperature, and your figures may be different. So you have to do your own calculations. You can't just go by my calculations, because that was based on my machine and my environment. And you have to now do your calculations for your machine and your environment. So in my case, the labs here are very cold. I think you all remember that. 60 degrees is the minimum temperature, normal temperature in this lab right here. So we needed to warm our water based on our environment. If you're at home and you have a warmer temperature at home and conditions are different, you might have to actually drop the temperature of your tap water in order to get the right temperature of water to begin your initial mix. So if that's the case, calculating ice weight is what you're going to need to learn how to do. So we're going to go through that, and you have your little worksheet, so you're going to bring that out so you can follow along. So here are some temperatures that you need to first have on hand, okay? You need to know what your tap water temperature is. So that's literally taking some water off your tap and taking your thermometer to it and finding out what your temperature is. Desired water temperature. Well, that's something you've already calculated for your bread based on your machine friction and your desired dough temperature. You already know what that temperature, desired water temperature is. Remember, French bread for me was 103. It might be different for you. Then you need your tap water, your total water weight. So in the formula for your French bread, the total amount of water that was necessary to make the dough, which is, remember, the whole hydration, all the water that's in there, that's that number, okay? That's how many ounces. So now that we've got those temperatures and those amounts, we can begin with our calculations. So here goes the first equation. Tap water temperature, you're going to fill it in. And I'm using hypothetical numbers right now, so I set my tap water temperature that's here in the lab is at 56 degrees. Desired water temperature, I'm going to say 32 because it's rather cold in here, so I would usually have to warm my water. But if I were in a warmer environment and I needed cold water in order to get to my desired dough temperature, I'm just putting in 32. Tap total water weight is 23 ounces based on the formula that we're using. Okay, so tap water temperature is at 56. And we're going to now subtract the desired water temperature, which is 32, and that is going to give us our temperature decrease. So that's 24 degrees. Okay, we need to drop our temperature 24 degrees. Now we go on to the second part of our calculation. What is the total water weight for the formula that we're using? We have it at 23 ounces. We're going to multiply that by the number, the decrease in temperature, 24. And what is that going to give us? Gives us 552. Now we need to go to the second part here. Tap water temp is 56 plus 112 factor. Now this is a given factor, and in lecture we'll talk a little bit more about this number here and why it's 112. This is going to give us 168. Now the second part is that you're going to take your factor A and factor B and you're going to divide them. Dividing them, that's going to give you how much ice you need to drop 24 degrees based on your water temperature. Okay? So this is how much ice I need. If I want to drop my water 24 degrees, I need to scale 3.28 ounces of ice to go into my water that's going into my formula. But don't forget, you're not adding an additional 3.28 ounces of ice to your total water weight. You need to subtract the weight of the ice from the total amount of water, which is 23. So you take 3.28 ounces out of the 23 ounces, and then you add your ice. So you have the same amount of water in your formula. So you're not changing the hydration. Okay, very important that you do that. That's that very last step. 23 ounces of water is what the formula called for. I'm going to subtract the ice weight, and that is when it is going to tell me how much tap water I need to add to those 3.28 ounces of ice to get my temperature right where I need it. So it's going to be interesting to find out when you all do your calculations to see whether or not you will need to do this particular part of the calculations, or you'll need to warm your water. And we'll talk about that as we go through each of our production